Hi, in this video I'm going to show you how to do a hypothesis test of a population proportion P. To do this test I'm going to go into the Stat menu and then I'm going to arrow over to the Test submenu, and the fifth item down on your calculator is one prop z test, and that's the function we're going to be using. So let's take a quick look at that. This is a pretty simple test to do. It takes just 3 numerical inputs and then you indicate the type of test you're doing, either a two-tailed test or a left tail or a right tail test. I have an example set up that we can work through to demonstrate how this function works. So let's take a look at that. According to a study done by the National Center for Higher Education Management Systems, in 2006 in Colorado the public high school graduation rate was 70.4%. In 2009 an administrator with the State Board of Education wants to see if the graduation rate has changed since then. So we randomly chooses several high schools and finds that of 1,685 students who were 9th graders 4 years earlier, 1,217 have graduated in 2009. So this result, being slightly greater than 70%, prompts the question, at the 5% level of significance, is there sufficient evidence to conclude that the 2009 high school graduation rate has significantly increased from the 2006 rate? Okay, so what you need to do is, once you've determined that this is a population proportion that you're going to be testing, is to pick out the pieces of information in order to do the test. And the first piece of information we need to find is the population parameter, or that population proportion that we are testing. And in this case we're looking to see if 70.4% is still a valid parameter. So we're going to type in that value, 0.704. The next quantity you're prompted for is x, and x is the number of successes in your sample. So that would be, in this case, the number of graduates who were 9th graders 4 years earlier. And in this case that's going to be 1,217. So that's x, and then below that n is your sample size, so that's 1,685. Okay, now the last thing we need to input is the type of test we're doing, and the question is phrased, we're asking if the graduation rate has increased from 70.4%. That's basically a statement of the alternative hypothesis, and in this case that would be a right tail test. So I'm going to come over and arrow the greater than P0 symbol and select enter. So let me just restate what this line is about. You have the option of the proportion being not equal to P0, where P0 is 0.704. That indicates a two-tail test. The proportion is less than P0, which would indicate a left tail test, and the proportion is greater than P0, which would indicate a right tail test. So basically that's a statement or input of the alternative hypothesis for your test. Once I've got all that information entered, I hit calculate, and let's see what the output tells us. The first line is basically a restatement of that alternative hypothesis that our test is. We're seeing if the proportion is now greater than 0.704. Next we have the test statistic, z, which is about 1.64. Now in some textbooks the test statistic is denoted by z star. In other books it'll be z0 or z with a subscript 0. Here on the calculator it's just z, that's your test statistic. And below that is your p-value, which in this case is about 0.0503, so just a hair greater than 5%. Next we have p-hat, and that is your sample proportion. So that's equal to x divided by n, or in this case 1,217 divided by 1,685. And so that comes out to be about 72%. And finally you have a restatement of your sample size. So at this point with the p-value you have enough information to go ahead and make your decision and state your conclusion. Since we find that the p-value is actually slightly greater than alpha, alpha's 5% here, and so 0.0503 is slightly greater than that, our decision is to not reject the null hypothesis, and then we would state our conclusion as there is not sufficient evidence to conclude that the graduation rate has significantly increased from 70.4%. Okay, so that concludes how to do a hypothesis test of a population proportion. A couple of things I want to point out. You'll note that in the name it says z-test because we're using a standard normal distribution model to compute our test statistic and our p-values. And you need to check your assumptions before you do these tests. You want to check that your sampling distribution is approximately normal. And I'm going to refer you to these assumptions I've listed here that you would do before you begin the test. The first one, NP times the quantity 1 minus P, is greater than or equal to 10. That assumption, if that's valid, assures that your sampling distribution is approximately normal, and so we can use the normal model and this function to do the test. Some books will list that as NPQ greater than or equal to 10. The other assumption is just that your sample size is something less than 5% of the population, and that just assures that your sample, the elements of your sample are all taken independently. The last thing I'll show you is back in the test function. I'm going to go back over to the test submenu and choose 1prop_z test again, and then I'm going to arrow down to the draw menu to show you what the test looks like. You'll want to make sure that your stat plots are all turned off and that your y equals menu is off also. And when I choose draw, it brings up that standard normal distribution curve, and then it shades the proportion of the curve corresponding to the p-value. So that's this dark area here of 0.0503. And the boundary of that shaded area would be where your test statistic sits at about 1.64. Okay, that concludes how to do a hypothesis test of a population proportion.